Hello everyone, good morning. My name is Shoyombo Abdulatif. I'm a student of LASU Lagos State University. Today we're talking about motion in physics. We see everything around us moving, physics deals with physical nature of the universe. It's everything we see in daily and every time of our lives. We see a moving car, a flying bird, a rolling ball, bicycle, everything. But what's the theory under it? What's the theory under it? Don't forget, physics deals with physical nature of the universe. Now, let's dive into it. So, I'm teaching motion. I've said it before. Mm, what is motion? It's very simple, right? It's very simple. In a layman's language, it is motion happens when an object changes its position with time. Yeah. Example, if something moves from one place to another, we say it's motion. Yeah, that's motion. Or we call it transportation from one place to another. That's motion. So imagine mm, imagine a car moving from this angle to this angle. That's the motion. Obviously, yeah, that's the motion. Now let's talk about rest versus motion. Yeah, under motion there is a rest. Yeah, cause there's no how a functioning thing will be without rest. It will collapse. That's just it. It will collapse. So under motion there is still rest. Now let's talk about rest versus motion. An object is said to be at rest if its position does not change with time. That's very straightforward. Yeah, that's very straightforward. An object is said to be at rest when its position does not change with time. That's very straightforward, I've said before. While motion is when an object changes position with time. Motion depends on the reference point. Motion depends on reference point. For example, if you are sitting inside a moving bus, you are at rest relative to the bus, but in motion relative to the road. I don't know if you get that. When you are inside the bus, your body is at rest, but the car is moving. You are resting and the car is on motion. The motion does not concern you, so that's motion. Now, under motion, there is distance and displacement. Distance is the total part covered by an object. Motion from one place to another. Distance, total part covered by an object. Distance is a scalar quantity because it has magnitude only. Only, that's very straightforward. While displacement is the shortest distance between the starting point and an ending point, including direction. Hmm? Let me say it again. Displacement is the shortest distance between the starting point and ending point, including direction. Displacement is a vector quantity because it has both magnitude and direction as the two. Let's give an example. I don't have a board, so I won't be calculating anything on the board. It will just have to be oral. Oral. I won't be writing anything. So, if a student walks 3 meter east and 4 meter west, ah, the distance is 7 meter. That's 3 plus 4. That's the total distance. You get it? East, west. A student walks. A student walks. The total distance of the place he both covered, that's 4 plus 3, that's 7, obviously. Wow, the displacement, it will be the subtraction, that's 4 minus 3, that's the displacement. It's very straightforward, it will be very easy to understand. I'm doing just 20% of it. I can only explain. You go deeper by yourself to your physics textbook, you learn more about it. Now, under the motion, there is speed. Speed. Ah, thank God you know speed. Speed tells us how fast an object moves. Many people have watched Flash. That's what they call speed. Speed. Now, under that speed, it's physics, physical nature of the universe. Don't forget. It has formula under it. It has law behind it. So, how do we calculate the speed? How do you think we calculate it? Distance over time. Distance, the total distance over time. Everything deals with time, 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 time. Even life, it is time, time, time. And moreover, the SI unit of speed is meter over seconds. Why is it meter over seconds? You want to ask, right? That's a good question. Distance is calculated by meter. Meter. Wow. Time is calculated in seconds. 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 That's just it. Now, type of motion. There is translational motion, rotational motion, oscillatory motion, and random motion. Now, what's translational motion? The whole object moves from one place to another. Example, a moving car. Let me be fast with that. That's very straightforward. Rotational. The object moves around a fixed axis. Oscillatory motion. The object moves to and fro from a fixed, just like pendulum. You know, when you pull a bulb and a rope, when you swing it, it moves from one side to another. That's what is called to and fro. To and fro. The last but not the least is the random motion. The movement has no definite parts, like no parts. Example, smoke. You see, maybe when they burn something, when the smoker smokes or a gas does not have definite zigzag manners, you get, that is random motion. That's very straightforward, I think.